Hello, welcome back. It's been a while actually, I haven't done a video. I've got a new camera, Sony ZV-1, courtesy of Sony, the company who I work for, Sony Interactive Entertainment, but got this one in a staff sale, 200 quid or 220 quid or something. So that's pretty good, and look at it, it looks pretty nice. So I thought I'm just doing, this is more of a test video, just to test the setup. I'm going to get a new mic, because this one is slightly damaged, but slowly improve my setup. But I thought what I would talk about today is actually some Rust macOS stuff. I ported my my Rust graphics engine, Hotline, which there's some other videos on here about it, and it's on GitHub. You can find it. And it was a Windows engine originally, and I'd been just doing D3, D12. Rust was the kind of biggest project that I've built in Rust, mainly just to kind of learn about the language. And it's a game graphics engine, but that's kind of my job. So it was something that I knew well, and I wanted to see how would you do it in Rust. The thing about working on Windows all the time is that I've got a Mac laptop because they are superior. So sometimes I want to work remotely, and that's led me to do this port. So it's taken. I started this actually on the plane to SIGGRAPH 2024, and I'm going to SIGGRAPH 2026, and I've finished it now. So it did take a while, but let's just. I'll just build, and then I'll run, and then I'll show the working thing, and I'll write a blog about it. So this is now merged into master. I'm still on master. Sorry, I know that's not very woke of me. But this was, the original main branch name, wasn't it? So as ever, I should have been a bit more prepared here, but I ran into some build errors, switching back to the macOS branch. So I actually struggled on and I fixed it, trying to write the code myself without just asking AI to do it for me. So yeah, a little bit of messing around. I should have really been a bit more prepared before recording the video. Right, finally, I wrote that code myself as well instead of asking AI. It took me a good little while just to figure out this. It also makes you remember how much of a pain Rust can be at times. I mean, I just want to check if the file exists, but then I've got to unwrap the error, and then I've got to return it. Oh, mate. Right, so what I had to do was add a handling for a shader that didn't exist, because some shaders don't yet compile on macOS. This particular one is frustum culling and compute shader based frustum culling, and that's because any of the indirect draw stuff hasn't yet been implemented. That's going to be a bit more fiddly, but I did get bindless kind of architectures working. Okay, so it has built now. That was a bit of an ordeal. Well, probably good exercise to keep my brain working. I'm trying to not use AI coding as much because I just hate it now, really. But anyway, so let's run. Let's have a look. Actually, we can look at. I've got samples. Right, we'll go through the basic examples first. Right, so we start with window, and that is just basically an empty window. So building. Okay, so window is an empty window, and it says main loop. The window actually is using win-init. Win-it. If you know what a win-it is, then I don't know. Don't call it that. So then once you have a window, you can look at a swap chain. Some platforms, you have to create the swap chain yourself and handle the synchronization. The swap chain is just a gradient color, and these ones have been working for ages. Like I said, I started working on this 2 years ago on the plane to SIGGRAPH, and I think I had swap chain then. There are some other secret platforms that you have to implement the swap chain for, but we can't talk about those. swap chain. Okay, so then once you've got the swap chain, you've got triangle, which is a basic triangle, and you know, the classic graphics triangle. So here we go, and we print out some info. This is the device adapter info, so it's an Apple M1 metal, 5 gig of video memory, shared memory basically. So then you get triangle. Then once you've got triangle, we have well, we've got bindful and bindless. So okay, here we go. So this is bindful. Boop, 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 boop. And they are little monsters. They are actually AI slop. So don't sue me. Right, so code-wise here for bindful, if I can navigate my code base. Right. Yeah, we create some textures. Here they are. We create render pipeline as such, and then what we do, we call the command buffer, and we can call set binding on the pipeline, and these use the like, you know, on the HLSL shader. I should probably show the code in the shader code. Bindful. So we have texture 0, 1, 2, and 3, and they are on T0, T1, T2, and T3 on the registers in HLSL code. And then in the here we use basically it's shader resource, which is T, because it's a read resource, a T sharp as it might be called on some other platforms. And then you've got 0, 1, 2, and 3. So these are basically that T0, T1, 2, and T3. So you can use that mechanism, which is quite handy. If you're not doing bindless stuff, you can set a binding, and they can also reside in a heap. So you say, from this heap, I want to set this texture on this slot, which is a fairly nice API. And I had to do some changes to get that working. So that's bindful, and it binds for discrete textures. So yeah, on metal, like I say, there's two heaps. You have a heap of buffers and a heap of textures, and based on the type of the resource in the heap, it knows which one to bind, because D3D on the front end doesn't really have that distinction, and I was able to get it all working without changing the API of the graphics API, so I was quite happy about that. And this is quite useful, the set binding mechanism, like ImGUI uses it to set the font texture, you know, and things like that. The rest of the code base and like the main engine is sort of bindless orientated, but having this is quite handy for like quick things, and sometimes you don't want to have to think about bindless, because if you do bindless, you have to then pass the shader resource view index, and you have to use that in the shader to index into the bindless array, and there's a bit more bookkeeping to it, and sometimes you don't want to have to deal with that. But the test is there to make sure it works, and then we have the cargo run example bindless, and this is a similar thing. It's some different images, but the way that they're rendered, or the way that the binding model works, is different. And then so similar code, create some textures, and what we do here is we just set the heap on the CPU side. We say, here's the shader heap, we set that, and then in the shader, we use these push render constants on the command buffer, and they're used in the shader to look up into the array. Are these fixed? SRV indices. Here we go. Yeah. So SRV indices. So that the SRV indices is like the texture SRV indexes. When it gets allocated into the heap, there's a shader resource view, is a handle, and then that's the position it is in the array when you index into it. And so to show that in code, bindless, we have an array of texture this time in this code, and then we get the handle and we index into the array. So that's how bindless works, and that's how bindless and bindful work side by side in macOS, and it also works on D3D. Push render constants is a little bit different on how it works on macOS as well, actually. So when we push a render constants, you can push them with a offset when you push on D3D, but Metal doesn't actually support that. So what the command buffer does is track any updates to render constants, and every draw call, if they've changed, it will push the render constants. So it allows you to essentially mutate all of the constants that go to a specific shader with offsets, and then you just update them per draw call. But I'll cover this in more detail in a blog, because it's just a bit easier to talk about it in that format and have examples and stuff like that. So next one, so we've got bind for bindless, then we have compute, which I added this new one just because it's handy to have these simple examples to be able to just run. This one is a animating Julia set, compute shader, compute read write texture, basically, which is quite handy just to making sure read write textures work, or the compute pipeline works. Code wise, I don't think it's anything particularly interesting there. It's quite simple, but what do we do? Create a bunch of pipelines and that, and then begin a compute dispatch. That's it. It's kind of, I don't know, there's a blit to copy it to the back buffer. Actually, forgot about hello world. I mean, it's just the entry point without a window or anything. ImGUI demo. I mean, it's just ImGUI, but it works, so we'll do that. And by the time you get to ImGUI, when I'm implementing these kind of step by step, you know, you have to have mouse inputs and keyboard inputs, and you can't, it doesn't have viewports at the moment yet. That's something I want to implement, because these can be dragged out on Windows, on the platform Windows. But yeah, that's ImGUI demo. And once you've got that, you kind of got quite a lot of the rendering pipeline. I haven't implemented play video or ray trace triangle. I've not done ray tracing yet, like I said, and I've not done indirect drawing. But the main thing about Hotline is the kind of the plugin system and architecture. Okay, so this is the client now running. This is just a triangle, single draw call. So it has ImGUI, we've got a window, and then this is actually rendered inside a plugin, so it can be hot reloaded. There's a demo of that all happening. Like I could do one now. I'll just go through the demos actually. So the first one, this is just a normal draw call, draw. Then we have draw indexed, which is a cube with a draw call with an index buffer. Draw push constants, where we push the render constants, like I was mentioning before. It pushes the world matrix for each of these cubes. Draw indirect isn't implemented. Indirect drawing is quite different of how you generate command buffers and how you populate them on the GPU in Metal, and it definitely needs quite a lot more work. It's not going to be very portable, the shader code, certainly, so I need to think about that. But geometry primitives are like the canonical one. Actually, I should check this. Yeah, okay. This is geometry primitives, which are the canonical demo of Hotline. I actually made them using the hot reloading, and it was one of the first things I worked on. And then we have different kinds of instancing. So this is instancing done with a vertex buffer. It's like a large number of draw calls. and then you bind two vertex buffers, one with different step rates. That's kind of old school instancing. And then there is this is draw structured buffer instancing. So the way this one works is you have a separate buffer you bind. It's just a shader resource. It's a T-sharp buffer, and then you index into that using the instance ID, which is in the vertex shader. So a little bit more flexible, and the vertex buffer instancing is a bit old school now, and I know that people are sort of bypassing vertex buffer kind of stuff anyway, even for the normal geometry, and just going basically just on pure buffers. So that's maybe something to consider for the future. But also have bindless texture, which is same as the bindless sample I showed earlier, but it's just on a draw call, and the meshes in the scene are being added via Bev ECS, so that's kind of like the engine that gives you more like entities and meshes and that kind of thing. Tangent space normal maps is just basically a test to make sure all of the tangents and of the normal maps are correctly transformed. Bindless material is quite an expensive one. It's actually running quite slowly, and I had it much more optimized than this, but basically for each draw call you have your draw call and then your material ID, and the material ID is a lookup, and you look up the material in the shader, and then the material is a lookup of the textures that it should use. So it's like a couple of levels of indirection and all bindless, but I mean, they look kind of similar, but there's a load of draw calls, and there's some lights in there as well. Some lights and some normal maps and textures. But running very slowly. Point lights is just a little sort of gen art thing I made, and this was kind of why I made the engine. I wanted to do these sort of things. Just some animating lights, point lights, with some geometry and spheres in the scene. Spotlights and directional lights are, again, just different kinds of lights, and they're just a test for the engine functionality. Just a directional light with no shadow there. GPU custom culling not implemented because it's indirect draw. Cube map, this is just so you can check that cube maps are loading and the MIP chain is properly populated. Texture 2D array is a texture 2D array type, not to be confused with the bindless array. It's a texture 2D array is like slices. These are like, each slice of it is an animation frame, and texture 2D arrays have to have the same dimension. Each slice has the same dimension. It's really a 3D texture, and this is a 3D texture, which is a signed distance field. This was generated in my C++ game engine as part of this signed distance field shadows sample, and I just serialized it out to disk, and it's a ray marched signed distance field there. Read write texture, it's a 3D texture that's being written to by a compute shader with some kind of animating noise and color patterns. Multiple render targets, just basically these are different render targets that are rendered to at the same time, like you would do for a G buffer. This is just some sort of weird terrain thing I did. It's more just a test, right, for the functionality. Raster states, very basic test. Blend states, they're just the different rendering pipeline settings, just to make sure that everything is hooked up. Generate MIP maps is not actually implemented. These are all sampling the top level MIP that needs to be implemented or hooked in, because these should be lower res basically. Shadow map is a single directional shadow map with PCF and with shadow compare filters. Dynamic cube map is a dynamic cube map. So basically it renders the cube map faces and the updates them every frame and renders those little things into it. Omnidirectional shadow is a cube map shadow essentially. So you get nice kind of point light shadows. I think they look quite nice. And then this is the final one. I've just hit an issue there that there's some leaky memory leak, or resource leak. So there are still tasks to be done. But it was this one. Basically, this is just, image-based lighting PBR with some teapots and some different materials. Material system. I think that's the last one because ray tracing pipeline, ray tracing shadows don't work. Claude, this is just, I was trying to get Claude to do some coding, and I mean, it looks alright, but it's not that good. I mean, I had a bit of a rant earlier about Claude because I had it here, the instance actually open, and I was trying to get it to fix a shader for me, a shader compilation when I came back to this project. Shader was failing, and it was doing all sorts of stuff, and it was trying to pipe things into the shader compiler, and literally the issue was, if I can just do undo, I had this group accumulated thing, which this was basically breaking compilation. It's not actually used in the shader at all. So I literally just deleted it, and this is fixed shader compilation. But Claude had started editing my, shader compiler and propagating things through and saying, oh, you need to omit this code. And it was just like, the code is dead, mate. It's just stupid. Absolutely stupid. So, right, that's macOS, Rust, Hotline. It's still got a few bits to go, but it's kind of working now. There's some performance issues that you saw there, which weren't happening before, so I need to look into that. But I had it running at a better frame rate than that. And it just means I can kind of do some stuff in the engine if I want to, on the go, on the Mac laptop. I might not do everything, and obviously it's not, as you get into more advanced modern graphics techniques, I think the graphics APIs diverge a bit. So like I say, all the stuff to do with indirect draw is going to be quite different. And if you build your engine around that, then, you've got to kind of probably hand roll the shaders somehow to be able to do metal command buffer population versus HLSL, draw indirect args population. So that's something to think about. But the bindless architecture and the kind of the general running of this, it's like a very much D3D12 centric engine with a wrapper, front end that's custom, and then it has a macOS backend that worked, and I didn't have to change that much to get that working in terms of the interface, or the interface pretty much remained the same. But all the details of the bindless stuff, there was quite a lot of kind of challenges involved in that, and I'll write a blog about it because it's just easier to do that in a bit more detail. So anyway, this is currently the World Cup. England tonight. England, come on, England, and let's beat Norway to get to a semi. And a semi with Argentina is gonna be spicy. But anyway, that's me for now. Bye.